the subcrustal lava bed became well-nigh worldwide, and this compensated and stabilized the fluctuations due to cooling, contracting, and superficial shifting. Volcanic eruptions and earthquakes continued to diminish in frequency and severity. The atmosphere was clearing of volcanic gases and water vapor, but the percentage of carbon dioxide was still high. Electric disturbances in the air and in the earth were also decreasing. The lava flows had brought to the surface a mixture of elements, which diversified the crust and better insulated the planet from certain space energies, and all of this did much to facilitate the control of terrestrial energy and to regulate its flow, as is disclosed by the functioning of the magnetic poles. 800 million years ago witnessed the inauguration of the first great land epoch, the age of increased continental emergence. Since the condensation of the Earth's hydrosphere, first into the world ocean and subsequently into the Pacific Ocean, this latter body of water should be visualized as then covering 9/10 of the Earth's surface. Meteors falling into the sea accumulated on the ocean bottom, and meteors are, generally speaking, composed of heavy materials. Those falling on the land were largely oxidized, subsequently worn down by erosion, and washed into the ocean basins. Thus the ocean bottom grew increasingly heavy, and added to this was the weight of a body of water at some places 10 miles deep. The increasing downthrust of the Pacific Ocean operated further to upthrust the continental landmass. Europe and Africa began to rise out of the Pacific depths along with those masses now called Australia, North and South America, and the continent of Antarctica, while the bed of the Pacific Ocean engaged in a further compensatory sinking adjustment. By the end of this period, almost one-third of the Earth's surface consisted of land, all in one continental body. With this increase in land elevation, the first climatic differences of the planet appeared. Land elevation, cosmic clouds, and oceanic influences are the chief factors in climatic fluctuation. The backbone of the Asiatic landmass reached a height of almost 9 miles at the time of the maximum land emergence. Had there been much moisture in the air hovering over these highly elevated regions, enormous ice blankets would have formed. The Ice Age would have arrived long before it did. It was several hundred millions of years before so much land again appeared above water. 750 million years ago, the first breaks in the continental landmass began as the great north and south cracking, which later admitted the ocean waters and prepared the way for the westward drift of the continents of North and South America, including Greenland. The long east and west cleavage separated Africa from Europe and severed the land masses of Australia, the Pacific Islands, and Antarctica from the Asiatic continent. 700 million years ago, Urantia was approaching the ripening of conditions suitable for the support of life. The continental land drift continued. Increasingly, the ocean penetrated the land as long finger-like seas, providing those shallow waters and sheltered bays which are so suitable as a habitat for marine life. 650 million years ago witnessed the further separation of the land masses and, in consequence, a further extension of the continental seas. And these waters were rapidly attaining that degree of saltiness which was essential to Urantia life. It was these seas and their successors that laid down the life records of Urantia, as subsequently discovered in well-preserved stone pages, volume upon volume, as era succeeded era and age grew upon age. These inland seas of olden times were truly the cradle of evolution. Presented by a life carrier, a member of the original Urantia Corps, and now a resident observer.